Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We will continue our discussion to the new topic about the atomic theory. This atomic theory, in the assignment, I asked you to make a diagram about how development progress of the atomic theory from the beginning to the end. Here in this slide, I will explain about the short review about the topic. To make you more understand about the atomic development theory, I attach one movie documentary that very from the BBC, which is the title is The Clash of the Titans. Okay, let's start with the theory which is being by the Democritus. Democritus is the philosopher Greeks, which is for the first time, he brought us the concept of indivisible particle, which give it the name as atomos, from atom from the atomos, which is uncountable or indivisible. This concept, especially not accepted by many of his contemporaries, such as Plato and Aristotle, but even though this is unaccepted by them, it still endured until 19th century. And now we will start with the classical theory of atom. The first theory atom, which is we know here are the classical of atom theory brought by Dalton. The Dalton theory it's stated especially in 4 points. The first point it's still coherent with the Democritus statement, which elements are composed of extremely small particles called an atoms. Second, all atoms of a given element are identical, having the same size, mass, and chemical properties. The third, it's very familiar that we have discussed it. It's about the compounds and composed of atom more than one element, and the chemical reaction, which is show you about the law of conservation of mass. It's only involve the separation, combination, rearrangement of atoms, and does not include their creation or their destruction. Here are the visualization of the atomic Dalton's theory from the second point that the atom from element X and element Y will have the same size and identical. The next experiment which involved by G.G. Thomson that he measured the mass over by charge of an electron and he got the Nobel Prize in the physics. Here the cathode ray tube by J.J. Thomson. You can see here the picture show to us when only the electric field is on, the rays strike point C when both the magnetic and electric fields are off or when they are both on but balanced so that they cancel each other's influence. The rise strikes point B. According to electromagnetic theory, a moving charged body behaves like a magnet and can interact with an electric and magnetic field through with its path. Because the cathode ray is attracted by the plate bearing positively charged and repelled by the plate bearing negative charge, it must consist of negatively charged particles, and then we know these negatively charged particles as electrons. The Thomson give models of an atom and electron. We know about the racing cake giving the visualization by Thomson. Thomson gave the visual Thomson gives some forecast that the electrons pair around the surface of an atom and positive charge spread over the entire sphere. This is the Thomson model. Okay, perhaps it's very familiar. It's like good time cookies. I think the chocolate chip spread on the surface. Experiment show to us how he can calculate the mass of an electron, and then now in the Nobel Prize we may have a conclusion that the atomic number the mass of the electron could be measured. Rutherford experiment is one of important in order to the positive charge which is in the nucleus. Alpha particle, here we see that the atom positive charge is concentrated in the nucleus. You can see that the alpha particle emitted from to the gold foil and then surrounded by the detecting screen in order to measure how many any part of the light that will be reflected or it just only through past the foil. It's amazing that Rutherford found that the light not only just pass by, but we can may also found the reflect light, which is the part of an atom that could reflect the alpha particle. It's only a positive charge. And Rutherford experiment now to there is a nucleus in the atom which is has a positive charge and an opposite of electron, so it could reflect the light. What happened here that then we also know that the mass of the proton is bigger than the electron. The mass is 1840 times of the mass of electron. Here we also know that Rutherford's model that we see here, models of the Rutherford not only propose about the existing of the proton but also the existing of the neutron.